Okay, I'm recording a little late. It's 9:25 in the evening, a lot later than I normally record, but I kind of spent the day making a lot of these charts and thinking about these things. And so I kind of left off this idea that I talked about the about box in each white pearl, and probably maybe every UniML object has an about box where you could put more of the grungy details of something it's more localized about that white pearl or whatever. It goes into more detail, like if it's a word, it might have its dictionary definitions, and then you have these connections between them, like where you start having this inference engine going. And I talked about in yesterday's video how you would depict it. And this is early, I just coming up with this, so it's likely to change a lot. The design's kind of immature still and new. But I didn't talk about how you would actually compute these values, like these weighting values, like confidence. Am I confident that this definition is right, or maybe it's a different definition I should use? So in this video I'm making tonight, I'm going to address those issues. And so let me go to my PowerPoint chart here. So, and then I also talked about a previous chart, lambda calculus and how to use that, and that's really under construction. I bought this book a while back and I just could not make sense of it, so I bought another book, and finally I could start making sense of this book. It's starting to click, and so I'm just on kind of the first chapter of this, or second chapter. So this is really immature here, and it's going to change a lot. This is sort of notional here. It's not just sort of, it's very notional. But the idea is you have these functions, and the functions could produce not just numbers as outputs, but functions as outputs. That's kind of the takeaway message. But, and this idea of graphics, I had this little saying here, so if I have a card here, grammatical. I've kind of started trying to get more organized, get notes, but I lose my notes, so it doesn't really work. Graphical grammar, like a spoken language, a written language has a grammar. So UniML it's a graphical language, it has a grammar too. So I talk about some of its grammatical rules, and once again, it's like they seem kind of complicated. Well, all languages, if they're expressive, kind of have complicated rules. Graphical grammars shouldn't be no exception, but they're pretty simple, and they're kind of intuitive because you can just look at them and sort of figure them out. Like you just look at this and say, oh, that kind of looks like a chip or a function. It's got pins. And so I make it similar to things that people should be familiar with. And so, but why go through all that bother? So here's my chart on that. Just let me zoom in a little bit here, frame this better. Is like, when you're building, like talk about spaghetti code, or you're laying something out and it's all hidden from you. It might be ordered or it might not be. You don't really know. It's hidden from you. But, it's sort of like you wire all this stuff up, and then here's our professor, here's our mad scientist saying, okay, now that it's all wired up, let's power up and see if it works. And it's like, what's the chances, of you get a wire wrong here? Here's his assistant, smart assistant, that used UniML to kind of organize things. He says, here's my part. So which is more likely to work when you power up? The more systematic approach that you see what's going on versus the haphazard approach are things that are in your black boxes that you don't really know what's going on. So that's the idea. So I think that packaging does matter sometimes. It does matter. That's why companies spend a lot of time on packaging. But an aircraft, you spend a lot of time packaging the avionics and the systems in airplanes to make them fit, or a car, or a robot, or anything. So a lot of this is packaging. So moving on to here is where I start talking about. There's this YouTube video. Let's see if I can find it here. It's not banned in the box. Let me go back to its recent. Not this one here. I probably won't be able to find this. It's about AI one. I should have brought it up. I think it's close by here. You can kind of see what I've been looking at, various things. Hops up here. It's basically this report that came out that Apple, I think it's Apple put out, is saying these LLMs can't do reasoning. They're not as smart as you think. And it's like, usually I'm looking for something, I can't find it. I can't find it here. Okay, I'm not going to be able to find it. I was hoping I could. But at any rate, it's somewhere here. Sometimes these are just further back than I think. Okay, I can't find it there. Let me just go back to here. That didn't work. But what I'm trying to do here in UniML is make it so it can do inference engines and things like that. And here's where I kind of looked at how to do it. I have this other UniML object called the wine glass. And the wine glass is sort of like for fuzzy logic. Instead of something that's being true or false, it could be 0.3 confidence or 0.3 true or membership value. And I have let me go to here. I'll head back to where am I looking for? Here. Here's where I show an example. Here's sparrow birds, sparrow, robin, turkey, penguin, parrot, ostrich, hummingbird, bald eagle. Here's bird attributes. Land birds, sea birds that can fly, that have flippers. These are, you can see here's my manifolder. This is the set, birds. Here's the members of the set, different kinds of birds. Here's subsets, are the topology. And then instead of having, normally I have little junction boxes, yes or no, which says there's some connection. I've used wine glasses here to show membership. So a sparrow and a robin both can fly. They're both land birds, and so they're not seabirds that can fly. They both can fly. So you can start seeing the comparison of all these attributes versus the birds, and so you can see which ones are alike. And then I have this overturned wine glass that shows when you kind of multiply all these together what the composite is. And so, and when defining these symbols here, and there's the C-ROMs of them, little pictures of the birds. That's just kind of helps navigational aids, landmarks. You can think of them when you're navigating. Like an aviator can find the landmarks, find their way around, and say, "Oh, I'm looking for a certain kind of bird, ostrich. There it is." So I don't have to read it. So, and so upright wine glasses versus overturned wine glasses, and I do this just so that they're just distinguishable, without having to look at the details. They pop. They have pop here. So going back to my chart, here I applied it to quantifiers. And let me zoom in here so you can see this a little more. Quantifiers, like here's, and I got this kind of drawn wrong, but here's a set X, and here's the members, X1, X2, X3, X4, etc. And then here are some, I've built in here some subsets, like some X's are blue, and some X's are green, and no X's are both blue and green. And these are just the names of the set. One X is large. One X is small. No X is can't read my writing, something. But anyway, you get the idea. X3 is green. And so I kind of overturned that one, saying we know that one's it's kind of done. It's not up for grabs anymore. And then you fill these wine glasses by their fuzzy membership functions. And also I'm starting to use these coffee mugs versus the teacups to mean bindings. So that's kind of what I used them like equality, but equality is just a strong binding. So if you want to bind two things together, like a junction box joins things, but it doesn't really join them strongly. It could be weak joining. And the black pearl joins them as meaning there's a teacup below it somewhere in an expression. But so I needed a different kind of binding, like for lambda calculus. And so this is where I'm kind of binding these together. Like I'm binding blue and set in the X together here through this, because we have the statement here, some X are green. So I bind X with green. So that's and all this is up for grabs here and changing. So, and here's where I kind of show what I showed the set is here's drawings that are easy for the human to see, Venn diagram. Here's drawings that are easy for the computer to draw and interpret, and there's overlap is what I'm shooting for. And to do that, this is like a computer science kind of thing. But over here, there's this human factors part, there's this artistic part, and then in the middle, there's this AI part to make it all kind of work together. And so so what I'm getting at is how will you compute those values, like these fuzzy membership logic values are up here. They were not up here, but I don't have charts on this. But my little definitions and weights and things like that, I'm thinking, we could have ChatGPT come up with those. We just need prompts. And so that brings me to my next chart here of the goal of, like I said before, the goal of UniML is to make people smarter. But it could also make ChatGPT and other large language models, et cetera, AI smarter as well. And the way it could do that is where you have this called tangos. I think that's teacher, something, navigator, something. That's what I end up, but these are kind of avatars. And what it is once again, you could take that away and just have the bubble, but that just kind of loses the pop. You got a pointing finger here. I had the version where you could just put a little pointy arrow there, but this works better. So the avatar could actually represent something. This could be ChatGPT, and this one could be, say, llama. And so they're embodied in your UniML model as avatars. And so you're going to ask ChatGPT something, you click on this and say, hey, ChatGPT, point out something. And it'll say, oh, you want me to point out this? I'll go there. That's what it is. And it could talk, and then you could click to here and say, llama, you do this. And you can have them talk together. You talk to him, and you're clicking on this. And so instead of just having a comment to you, the viewer, these things could also create prompts where this avatar isn't ChatGPT, it's sort of the ChatGPT liaison bot that interfaces between you, the user, and ChatGPT. It's kind of an ambassador. And so it could speak on the behalf of ChatGPT, or it could speak on behalf of you to prompt it. And so it could create prompts. And so now when it creates prompts, that chews up more of your time. Say you've got a limited amount of ChatGPT time, and you don't want to choose, and you ask one question, and you want it to spend an hour answering that question, thinking about it. And so here we go with the wine glass. We have here the bartender bot. So the bartender bot could give each one of these bots could have their own little glass of wine with them, and that's how much time they've got. You could have a ChatGPT say, what prompts are more important than the other prompts? So this is part of prompt engineering, but that can be built into UniML and portals. So it says, okay, this is a very important question. We need to know this one. This is a less important question. And so the bartender kind of fills up the wine glasses, and then that tells ChatGPT they could rack and stack which prompts are more important, which ones could be deferred to later maybe or not done at all. And so once again, this is building. I'm going back to here. What I'm doing is instead of having just all these things piled here, and this not a junky table, but a junky. You got windows. This window open and that window open and this window open. A book in your lap, and you've got your fingers, bookmarks all over the place. So that's kind of the junky table you have. Instead, you concisely model these and in UniML, and it cleans up your workspace. It makes it more efficient here. So here's an example here. So here was that my example of my sentence, which was the man with the red shirt with the white collar ate the apple, and then I turned it into sort of a mystery. Like there's a bomb that went off here, and that's a suspect, and we got to find that apple. Maybe we can get a DNA sample from it. Where is that apple? So it's not just the apple, but it's the apple, and so you can promote that to a, and all this is kind of OBE here. Here's what I did. See, I did this already. It's obsolete. I should use a coffee mug here to bind these things together. And I've come up with some new rules here. This shouldn't be my new rule is you normally can't put white pearls in this. This is right off the pass. I come up with my grammar, graphical grammar rules. You can't put a white pearl in this atlas box, but you can if you put a coffee mug on it. So if I had, these little rules like this, like that doesn't seem like a big deal. You just make these up, but it's like, yeah, but they have to work. And getting ones that work are kind of hard. So I don't have a coffee mug handy, but if you turn this into a coffee mug, then it's okay, because what you're saying is this is a bound white pearl now. It's bound to this query here, or this statement here, the statement here should be, you can look at it here. I didn't have it here, but subject and predicate, and it's the subject is, see if I can zoom in here, read this off of here. The man with the red shirt. It's that sentence here. So I just never finished typing it up here. So this statement is now bound, like the subject. Now the subject is the man. So it's not just the man as a phrase, a noun phrase. It's the man that might have planted the bomb that we got to find. And our bosses are breathing down our necks saying, you got to find this guy quick, or you're a heap of trouble. And so it's no longer just a sentence. It's a imperative. And this is a thing, a real thing. And so we've, and this is a form of transubstantiation. We've changed the substance, being just words on a page, a virtual page, to the actual human that's out there that may have done a dastardly deed. And the way you do that is you bind it with that coffee mug. So I'm kind of covering a lot of different things here because I'm fixing. So, and let's see where I showed it going here. The bot here then says, GPT, tell me more about this man. What man is it? This man. So it's pointing here. So here's the Tango, and it's talking not to me. It's talking to ChatGPT. It's as a prompt. It's a prompt, and then ChatGPT will answer it, and then it says, okay. Then maybe the answer might be shown here. Maybe it'll be shown like this. The answer comes on this side. I go here, rotate this. And once again, there's a million ways of doing this. So one right way, and maybe we get a different color. Then ChatGPT. So there's your prompt, and ChatGPT answers here. And then you can blow this up and make it bigger and all this. And ChatGPT says, we don't know much about the man other than he ate an apple and he was here. We have a webcam not a webcam, but one of those street cams that might identify them such and blah, 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 blah. So there you've, instead of having to go out of this into a chat GTP page and back, which is once again just another example of your cluttered display, you got to jump all over the place. This is where you concisely put it all together. And because this is what UniML is made to do. And so, then you can hide stuff that you don't care about. Like, I'm not worried about the apple, so I'm going to hide everything about the apple. I'm looking for the man, not the apple. There's another team looking for the apple, and they don't care about the man so much. So you can hide different things. So at any rate, this is showing how this is evolving, where there's and how this all plays together. So now I did a chart about how no more mice. You know, instead of having to use a mouse all the time and carpal tunnel. Now, mouse is good for certain things. I use it a lot. I use it too much. But certain things is just tedious to do, like very precise controls or, you know, or just long-term uses or certain things. So the idea is that you could just have, and I said you could use your cell phone camera, but maybe better like a webcam and maybe a couple other cams so you get different angles. So you could, and then some smart AI that just looks at the images and then you talk to it. So like here's this drawing. I can hold it up there and says, okay, here's this drawing. And then I point to something on it saying, this is a white pearl named Frederick the Great. Say, I'm doing a history. And I want it to go here. And when I'm speaking, this might be me. So that's not me, but it could be me. So and it's me, the avatar, living inside the model now. So when I talk to the model, I can have an avatar of me writing down what I'm saying. And I point here. And then say, oh, we want to make a 3D version of this. Like we put these things on stilts. So we want it this high. So we just put this ruler here and put it here. And then the chat GPT could come back and say, oh, it'll adjust the contrast. Like notice here. No, I did it someplace else. It could split the drawing into different pieces and change the contrast. I did that. I'll show that in just a second. So see here's the idea is the webcam is kind of streaming what I'm doing into a window into the model. So here's another example of it. No. Where is it? Here. Okay. It's like I talked about Windows tunnel vision. Like here's my screen. Here's a picture of my screen. And I can't draw a line from my Windows to, say, my keyboard that's sitting right there in front of my screen. I got a cluttered workspace. Or this wine glass I'm holding. Or I can't point to the stem of it using graphics. But I can if my cameras import that image, and now I could get rid of get beyond Windows tunnel vision, and that I can have my avatars point to things not even on my screen because they're on my screen because the cameras put them on my screen. And I'm thinking this is probably work. This is an alternative to say these glasses. You don't necessarily need these. These are maybe when you're out and about, but when you're sitting at your computer, you don't need these glasses. You just need a bunch of cameras that put stuff on your screen. And it has the same effect as the glasses. And so you might have one up here and one down here, one over there, maybe one looking over your shoulder. So 3 or 4 cameras. These webcams are pretty cheap. And then they are USB plugged in, and you have the software on your machine that processes stuff in real time. And as the machines get faster and they get AI chips in them, they're specially designed to do AI. They can keep up with it. So I'm saying that the mouse is never going to go away, I don't think. But it's going to become, oh, there's my chart there. It's slow. It's going to become, maybe you're not your primary, it's more of an auxiliary input. It's good for, clicking things. It's handy to have, but once you get really proficient at pointing and talking to machine, just pointing with your finger or drawing with a pencil, using props like a ruler, you'll probably then have to use the mouse less and less. So, so I think that's all the things I wanted to cover here. See, that was just, yeah, that's going back to an earlier chart. So, at any rate, this kind of covered a bunch of different topics, but this is all evolving because I just spend time thinking about it, and I think, oops, that wasn't quite right. I can do that better, and oh, this seems like it could be that, you know, or like, oh, instead of this Tango or whatever avatar just putting comments and tutoring the user, it could also do prompts as well. It could be, or it could represent, you know, a persona for a chat bot, you know, or you have different ones. And so all these things, you know, these duh moments, oh, duh, oh, or aha, or whatever. And so when I do those, I like to put them in a video, even though if you go to my, like here, go back to here, this is my Padlet. These things are all, most of them are really dated. They might be 1 or 2 or 3 years old and need updating. But spending a lot of time updating them, it doesn't really make sense when it's still changing, because, you know, I'll just, so that's just the fact of life here. Rather, I just put new stuff in, and I know what's new, and a casual viewer won't know it's new, but they probably don't care because not many people are watching this anyway. So that doesn't sound like a good use of my time, getting people up to speed when they're not going to watch it anyway. And if they do, they could probably figure it out. Vignettes, things, lots of different subjects I haven't covered. So let me end the video here. And the other thing, my commercial for here is, you know, what I see is there's a lot of websites, YouTube videos, channels I cover regularly, and a lot of them on AI and things. So when something comes out, like say Meta makes some announcement, you'll see 8 or 9 different videos all on the same subject. So you can watch one of them and you watch the next one. All of them pretty much are saying the same thing because they're just covering the same event. And you get a talking head there talking to you, and maybe a little bit of graphics. And they get lots of views. Meanwhile, you come to my video and you get stuff that you're not going to see anyplace else. It may not be good, but it's unique, and it's always something new. Even when I give big reviews, there are usually a few new things in it. That's why I'm doing it, to catch the new things. I kind of have to do the review to kind of get a running start. So you're not going to find, so that makes this different than the average bare website, because it's not reporting on what somebody else is doing, but it's reporting on what I'm doing. And it's what I'm doing today or yesterday, not. And so it's continuously updated. So, and it's evolving. So, and when somebody's reporting what somebody else did, they read a paper, but they're not firsthand. They're not like the inventor telling you what they're doing. There's some follower that's kind of following the inventors. But I'm the inventor here. I'm inventing UniML, for better or for worse. And I'm not implementing portals, because that's software. And I could try to do that, but I think that's not the best use of my time. There's lots of people who can implement good software, and I'm not one of them. But there's not many people who can invent something like a graphical ontology modeling language like portals. I mean, there's probably some who would do it if they ever thought of doing it, but there's not many who are going to think of doing it. And those that think of doing it, there are not many probably that could pull it off. Now, whether I could pull it off or not, I've had my doubts over the years. I keep saying, this is too hard, this is too hard. And I give up for a little bit, then I kind of rally and jump back in, get back on that horse and make a little more, or push the safe a little more. It's like pushing a safe, push it another few inches. It's heavy, it doesn't move easily, but I did budge it a little bit, and it's moving across the floor slowly. So, and it keeps getting better. I mean, you know, a lot of the things we do in our past, we wince every time we think about it. Like, did I really do that? What was I thinking? Or I was crazy. Or I was an idiot back then. It's probably still am. But and same here. I go look at some other stuff on UniML, and I kind of wince and think, well, that's really bad. I knew it was bad at the time, but it was the best I knew how to do. So I could see that it's getting better. So now it still probably has a long ways to go. So rather than blathering on, I guess it's blathering. Let me end the video here and have a good night.